You know what scares me is I don't even know like what these problems are gonna be.
Yeah. In exercise 5 through 22, a parameterization is given for a curve.
Wait, what?
That's like the section of problems that we're going to be doing.
We're not going to do all.
We're not doing all of them. Okay, part A says, graph the curve. What are the initial and terminal points, if any, indicate the direction in which the curve is traced? We're not doing that.
Okay, good, because I didn't understand.
Find a Cartesian equation for a curve that contains a parameterized curve. What portion of the graph of the Cartesian equation is traced by the parameterized curve?
What?
Sure.
We're doing the first part of that, the writing the equation, and that's where we're going to call it a day.
Okay.
Okay, starting with number 6. X is equal to negative square root of t. Y is equal to t. T is greater than or equal to 0. Okay, t has to be greater than or equal to 0 because
because it's in the under the square root. If it's negative, then that's no.
yes.
I was just giving you guys a chance to answer.
Right.
Yeah. Okay.
Right. All right, so I'm given these functions that have t in them. So I want to get to the point where I can plug it in and get a y equals something.
Okay.
So I need to figure out basically how to get t by itself in both equations so that I can set the other stuff equal to each other. Is basically what's happening. So how would I get t by itself in x?
So first,
Divide by the
divide by
negative.
-1.
There's something else I can do and not have to do an extra step.
Okay, you can make it like.
Square it.
That's, yeah.
So x squared is equal to t.
Oh, that gets rid of the square root.
Yes.
Yeah, because if you square t like under the root, it just becomes t. Like it just.
So then I can rewrite this as I'm going to replace t here with y, okay, because y is equal to t.
Right.
So x is equal to, x squared is equal to y. And that's the answer.
Oh.
That's all we're doing with it, is you being able to rewrite them.
So the point was to get t out of it.
Yes. Because you have two parameterized curves,
I still don't even know what parameterized.
I understand.
and we're trying to get one new Cartesian equation.
I know.
So Cartesian equation should tell you I only want x's and y's.
Right. Okay.
Simple enough. Even though I don't understand the terminology.
Definitely glad I'm not taking a quiz right now. Because if I came back and was like, what is it?
No, what?
Let's see.
I'm not harming you. Yeah, you're getting in. Maybe I should try the X and see if it makes me on that. The X. Is this one of them here, like?
Alright, it's just
Also tying your.
so this one is a little different just because of what we're given. So x is equal to sine of 2 pi t. Y is equal to cosine of 2 pi t. And 0 is less than or equal to t is less than or equal to 1.
Christian? No.
So in this case, we can't really get t by itself without.
Because it's stuck to something? Wait, no,
Well-
that sounds stupid. Why can't you?
Well, just because it's inside of the cosine and inside of the sine. So it's going to be really difficult to get rid of it. So we're thinking about what other formulas do I have that I might be able to use.
Oh!
X. Wait.
x squared plus y squared equals the a cosine
cos.
t squared plus a sine t squared.
Alright.
Yep. So x squared plus, oops, wrong color. X squared plus y squared is what I'm going to try to get. So then this is going to be sine squared of 2 pi t plus cosine squared of 2 pi t.
Oh wait, it's just whichever one's first. Oh wait, or do we switch it? Wait.
X is sine of,
No, I mean like, cause in the thing it's like a cosine. Oh, never mind. Never mind. I think that's just because it gave you a cosine t first. Is that why?
yeah.
Okay.
So
Just give me a
sine
second.
squared plus cosine squared is?
1.
So x squared plus y squared is equal to 1.
But
But
wait, sine squared plus cosine squared is
we're
1.
so right for that.
But what about the 2 pi t's?
Because it doesn't matter what's in the.
It doesn't matter what's inside.
If it's
Because
sine
normally it's
squared.
cosine x, or cosine squared x plus sine squared x is equal. And x could be anything.
If it just equals the same thing.
Oh, so we don't square the 2 pi t.
No, you square the
Just the
cosine,
cosine
or
or
the
sine.
sine, yeah.
But so
Okay.
if it was like sine squared of 2 pi t cosine squared of 3 pi t, you couldn't do that.
Right. The middles would need, or the middles, the insides would need to be the same.
Oh, you couldn't just go to 1.
Correct.
Okay.
I see.
Yes, I'm witnessing.
Alright. Going,
No to everywhere.
so, I didn't write this for an ellipse, but if we were to do for an ellipse, we would be given the same information, but this would be like b sine of t or whatever it is that it gives you, okay? So when we do, I'm saying that because we're going to do an ellipse problem. 14, x is equal to 4 sine of t, y is equal to 5 cosine of t, 0 is less than or equal to t, less than or equal to 2 pi. These problems are all blending together. So when we had our ellipse formula, it's over a squared and it's over b squared. Okay? So when we look at this is a, this is b. The number that's in front.
Okay.
I see.
So in our ellipse formula now, you're going to have x over 4 squared plus y over 5 squared is equal to 1. Now, with those, I just want you to be more aware of the problems themselves. The ones that were like number 6 is what I would be most concerned with you being able to do.
Okay.
Okay, where it was like x and y is equal to some like line basically.
Right.
So let's do another one of those. 16. Let's see. X is equal to 1 minus t. Y is equal to 1 plus t. Negative infinity is less than t is less than infinity. So I'm going to be working to get basically one of the variables by itself. We can do x or y, it doesn't matter, like to get t by itself. So which one would y'all like to do?
Y.
X.
Why?
Y.
Y.
YX.
Okay.
Sorry,
Y.
guys.
You got outnumbered, Josh. Alright, so y minus 1 is equal to t.
Fool.
So now I don't really need to solve the other one for t because I'm just getting ready to plug this in. The first one I did that so you could see what was happening, but it doesn't have to be solved. Basically, you don't have to solve for t in each one. So like in this first one, t was already solved for, and we went ahead and did in the other one more so because I wanted you to see it. You wouldn't have to do it in both. We could have gone straight and plugged in y here, and the process would have ended up giving us the same thing.
Oh, I see.
So x is equal to 1 minus y minus 1. So this will be y minus y, wow, 1 minus y plus 1, or x is equal to 2 minus y. We want y by itself, because that's how we know how to, graph a line. So x minus 2 is equal to negative y. So then negative x plus 2 is equal to y. What in the... Like a little thought bubble. All right, this last one I'm going to have you try on your own. Okay, it'll be the same kind. I'm not giving you a weird circle or ellipse one to do on your own. 20, x is equal to t squared, y is equal to the square root of 4 minus t squared. 0 is less than or equal to t is less than or equal to 2. So take a minute and try that one.
I'm already confused.
Well, so look at what you already have.
So x is already solved for.
You're so right.
So should we plug x into?
Well, so under normal circumstances, no, but this and this are the same, right? So I can replace that with that
X.
instead and not have to even solve for anything by itself.
I'm tracked.
So now try. What do we get?
I don't have the answer. I have a negative and
Well, I got y squared equals 4 minus x. Oh wait, I lied because I need to get y by itself. So y equals radical 4 minus x.
Yep. My answer's not negative.
Oh, so you didn't. So that's the answer. I tried going past that for some reason.
Yeah, no, that's all
I
you have
also
to.
tried going past that.
And also,
That's all you have to get. The other part of these questions that we're not answering is basically like it says something about what portion of the graph is traced by this, and so it's anything x bigger than whatever, like, or in some cases x smaller than. We're just not doing that part of it. Okay, make enough sense to sort of understand it. All right. So for this section, I'm only giving you 4. So 5, 9, 13, and 19. 9 is a circle. 13 is an ellipse. Okay. And then 5 and 19 are like the one you just did and the one that we already, like the principal of them. If I were to give you a circle or an ellipse on the quiz or the test, it would only be something like this. It won't be anything crazy that you're trying to manipulate and solve for.
What'd you say was a circle or ellipse?
Circle is 9, ellipse is 13. So I just want you to be familiar with this. It's not a topic that needs to be stressed over with what we're doing. Much later in calculus it does come up, but not in like this class.